Section 5.5 in Edwards' textbook, it's called variation of parameters method, which is a method to solve a non-homogeneous nth order linear differential equations with constant coefficients. The problem with annihilator method was it had two severe limitations. One was it only applies to ordinary differential equation with constant coefficients. The other limitation was the non-homogeneous function had to be in the form of e to the ax, sine of bx, cosine of bx, or any linear combination of them. So variation of parameters is a general method to solve what? Non-homogeneous linear higher order differential equations with constant coefficients, regardless of how f of x looks like, as long as it's continuous function on some open interval I. Suppose y1 and y2 are linearly independent solutions for a homogeneous equation. Let's say we have a second order non-homogeneous equation. First, we find the complementary solutions. So complementary solutions are obtained by setting the what? The right side equal to 0 and get your functions. Namely, in this case, let's say you got complementary solution. Let's say it came up to c1y1 plus c2y2. So c1y and c2 are called parameters. Now, the variation of parameter method consists of replacing the constants with functions of x, namely c1 with u1 of x, c2 with u2 of x. This is basically where the title of the method comes from, because we are allowing what these parameters to vary. So that's why it's called variation of parameters. So we let in these constants to be what? Functions of x, namely u1 and u2, in a way that the particular solution is u1 y1 plus u2 y2. So this is how the particular solution should look like. So our job is to get a hold of these two functions, correct? So this guy would be particular solution of the original differential equation. Now, differentiating what? Y of p, which happens to be equal to, what was it? u1 y1 plus u2 y2 gives us this expression. Of course, with respect to x, we get this. Problem is, since y of p contains two unknowns, namely u1 and u2, but we only have one condition to find u1 and u2, and that's the original problem. So basically, we have two unknowns and one condition. So in order to find u1 and u2, what we do, we have the freedom to impose a further constraint on what? On u1 and u2. So what happens is, if we take the second derivative of this guy, we're going to end up with u1 double prime, u2 double prime. So to avoid that complication, we're going to let the sum to be equal to 0, meaning u1 prime y1 plus u2 prime y2 is equal to 0. Remember, we don't set individual terms equal to 0. We set the sum equal to 0. Why are we doing that? Because we have the freedom to impose one condition of our own, because we're trying to solve for two unknowns, but we only have one equation. So we come up with the second equation, and that's basically what would be our condition on u1 and u2. So basically what happens is, if this sum, which is u1 prime y plus u2 prime y2 is equal to 0, so that sum disappears from y prime of p, and all you get is this. However, when you take the derivative of this, you are not going to end up with u1 double prime and u2 double prime. So that was the purpose of imposing that initial condition. So when you take the derivative, okay, and you kind of substitute these derivatives and the function itself into original equation, you're going to get something like this. But remember, y1 and y2 were what? Solutions for complementary portion of the problem. So these guys end up being 0. So all you'll be left is u1 prime y prime plus u2 prime y2 prime equals f of x. F of x is what? Your non-homogeneous function, which is on the right side. Consequently, to solve what? A non-homogeneous linear higher order differential equation with constant coefficients. Uh, so particular solution will be u1 y1 plus u2 y2, and the conditions which we going to what? Find u1 and u2 are these two. This is the one which we just imposed, y1 u1 prime plus y2 u2 prime should be equal to 0. And this is the one which we got by substituting all those, the function y of p and its derivatives in the original equation, and we got this. So these are the two conditions which enables us to find u1 and u2. So basically, those are the conditions which applies to any problem in this section. So keep in mind the first condition is y1 u1 prime plus y2 u2 prime equals 0. The second condition is y1 prime plus u1 prime plus y2 prime u2 prime equals to the function on the right side. So the idea is solve for what? u1 prime and u2 prime first off of this system of equations. And the way you solve for u1 prime or u2 prime, you can use elimination or what? Determinants, namely Kramer's rule, to find u1 prime and u2 prime. Once you find u1 prime and u2 prime, then you have to take the integral of the answers to get what? u1 of x and u2 of x. And once you get your hands on u1 and u2, then you know the particular solution, which is u1 y1 plus u2 times y2. But the final answer, so this would be like our final answer, would be what? c1 y1 plus c2 y2 plus u1 y1 plus u2 y2. Keep in mind, this is my what? Complementary solution, whereas the rest of it is what? My what? Particular solution. So let's take a quick example. Like take a look at a quick example like y double prime plus y is equal to secant of x. Notice the annihilator tables does not what have secant of x. So we really have to do it by variation of parameters. Keep in mind variation of parameters work for any problem, whereas annihilators work only for those problems which what? Um, the non-homogeneous function is either exponential or sine and cosine or linear combination of them, and the equation has to have constant coefficient, but the variation of parameters work for every kind of functions. All right, so um, if you set the equation equal to 0, the auxiliary polynomial is r squared plus 1 is equal to 0, so r is plus or minus I. Therefore, the complementary solution is c1 cosine of x plus c2 sine of x. Particular solution is u1 y1 plus u2 what? y2, which is u1 cosine of x plus u2 sine of x. If you let y1 to be cosine of x and y2 to be sine of x, the order doesn't matter who is y1 and who is y2. That's not important. Remember now I have to apply the conditions. Remember, this guy comes from the fact that y1 u1 prime plus u2 y2 u2 prime equals 0, right? This second equations come from the fact that y1 prime u1 prime plus y2 prime u2 prime is equal to f of x, which is my non-homogeneous what? Function on the right side of the equation. So now you got two equations, two unknowns. So the idea is what? Solve for u1 prime and u2 prime. Remember, this does not give you u1, u2. It only solves what? u1 prime and u2 prime. So it turns out if you use elimination or determinant method, u1 prime comes up to minus sine of x secant of x. u2 prime comes up to cosine of x times secant of x, which is 1. Okay? So u2 or u1 is antiderivative of this expression, and u2 is antiderivative of 1. So when you take the derivative of minus sine secant, you get natural log of what? Absolute value of cosine of x. When you take the antiderivative of 1 with respect to x, you get x. So the final answer is going to be what? So the particular solution will be what? y1 u1 plus what? y2 u2. So this guy is y1, this guy is u1, this guy is u2, and that guy is y2. So the final answer consists of two parts. The particular solution, which was what? Complementary solution, which was c1 cosine of x, c2 sine of x, and the remaining, notice they don't have a c in it, is my what? Particular solution, which we obtained that by using a method called variation of parameters. Thank you.